Okay, so you'll see in this lovely picture we have this airplane and some sort of tree. Who knows what kind of tree that is? We have two ideas that we're going to talk about here. And one of them, and it's kind of blurry, but this guy right here is angle of elevation. So this guy right there is an angle of elevation. And this guy right here up at the top is an angle of depression. It's moving down or going downward, and down is depressed, right? So those are the two different angles. But if you kind of look at the picture, it's not really a Where's Waldo, but it's kind of like that. If you look and consider, we have these lines here, these horizontal lines. Oh my gosh, here comes the geometry inside of this trigonometry lesson. We have two parallel lines cut by a transversal, so these are alternate interior angles and they are congruent. And then if I kind of, let's hope the undo button works here. It seems like it never really works when I want it to. Hey, it worked. I had to pause the video for that to happen though. So now, what we just said was this guy and this guy are congruent to each other. And then, notice what I can do here is I can draw a vertical line that connects these guys, and I just created a right triangle. Oh my gosh, look at all this stuff. So if I'm a plane trying to land, I need an angle. And then if I'm this tree at the very bottom, I'm concerned, is this plane going to hit me? Is it approaching at the right speed, at the right angle, so it stops before it gets to me or overshoots me? Ay, ay, ay. Anyway, angle of elevation, angle of depression, they're congruent. We can create triangles and then use our ideas of SOHCAHTOA. It's a pretty involved 2-minute conversation here. I'm just trying to be a little goofy. I'm just trying to have fun. So now here's our application problem that's associated with this idea. Okay, the height of an observation tower in a state park is 30 feet. A ranger at the top of the tower sees a fire along a line of sight that is a 1-degree angle of depression. So the key word here is this is an angle of depression. So the best way to approach these problems, and ask the question, we'll get to that, but draw a picture. So we have a height of an observation tower. So here's our observation tower, and it's 30 feet. Okay, so there's our 30-foot tower. A ranger at the top of the tower sees a fire. Okay, fire, woo, fire. Okay, that's supposed to be fire. So sees the fire, right? And so that's the ranger looking down. Well, there's a horizontal distance from the base of the tower to the fire, and that's what we want to know. That's x. Okay, well, this angle of depression is from the horizontal line down to this line of sight, and that is 1 degree. That makes this 1 degree. They are congruent, alternate interior angles. Two parallel lines that are cut by a transversal. Okay, so you've already discussed that. You've seen your geometry classes. And now I want to know x. I have an angle that looks like a 10, but it's a 1 degree. Okay, so I have opposite, and this is adjacent. So opposite over adjacent is tangent. So I'm going to take tangent of 1 degree, got to make sure my calculator's in degrees, is equal to opposite over adjacent. I would then go ahead and cross multiply, but here's the problem when I cross multiply. I got x times tangent of 1 degree is equal to 30. I got to solve for x. So that means I have to divide out the tangent of 1 degree. And don't forget, well, you should be okay without putting parentheses, but you might want to try, and that would tell us what x is equal to. We go ahead and crank this out, and we go ahead and get our answer. And we get 1,719 feet. And there we go, and that's it. So a little bit of geometry, a little bit of right triangle trig, and we can solve some fun application problems. Yes, these are fun. maybe they're not, but these are the problems that you got to be able to do.